geometry peeps. Wish me luck on my first very awkward, not looking at anybody but me video. The first lesson is going to be on volume of prisms and cylinders. And for starters, I want you to think about how many jelly beans are in this cylinder. Ever played that game? I love that game. I'm good at that game. I usually win that game, gotta tell you, because I kind of know a little bit about geometry. So, if you were to try to figure out how many jelly beans were in this cylinder, which I'm going to try to show you what the shape is on the bottom. Okay, there it is. It's a circle. All right. Most people just kind of look at it, throw a number out there, guess. Me though, I don't do that. Here's what I do. I hold it up and I count how many jelly beans are on the bottom layer. I count how many jelly beans fit on that circle right there. Then, remember that number, the number of jelly beans on the bottom. Then I multiply by, there goes a jelly bean. Oh well. Then I multiply by approximately how many layers of jelly beans there are in this container. And that works pretty well. I wonder why. Because it's pretty much the formula for the volume of anything that has a matching base, matching top, and a matching, I keep throwing jelly beans. Start over. Never mind. A matching top and a matching bottom. Since the top and bottom are both circles, what you'll do for the volume of something like this is you find the area of the base times the height. In this example, when I count how many jelly beans are on the bottom, that bottom layer of jelly beans, I'm finding the area of the base in square jelly beans instead of in square inches or something like that. So I'm finding the area of the base by counting how many jelly beans make up the base. And then I'm multiplying by the number of layers, which is the height. The volume of anything that has a matching top and bottom can be found using the formula. Volume equals capital B times H. Volume equals capital B times H. The B, the capital B, I hope you can see that, I can't really tell, but I'll write it somewhere else. The capital B stands for area of base. The base is whatever you have a match of, the top and the bottom, but don't think it has to be the butt of the thing. The base can be sitting, wish me luck, like this, and these two circles would still be considered the bases. You can find them because there'll be two of them across from each other. For cylinders, it's pretty obvious. If it's a prism, however, a prism, this is a prism. I don't know if you can see that very well. The bases would be the thing you have two of that match, and then the height is connecting those two bases with rectangles. That's what makes a prism a prism. So this would be a rectangular prism. This guy right here, this is a triangular prism. I don't know that you have to know the names of them, but this is a triangular prism because the two bases, the things that I have a match of, I have two triangles. So the base, capital B, would be a triangle. And then it's connected by three rectangles. So if I was trying to find the volume of this, I'd find the area of the triangular base times whatever the height is. Okay, now this formula only works if it has a matching top and bottom, which happens with prisms and cylinders. Let's see what else I have. This guy here, which side would be the base? Okay, it's the thing you have two of. So these two triangles that match would be the base, whether it's sitting like this, sitting like this, sitting any old way you want, this is still the base, the two triangles, okay? Connecting the two triangles is rectangles, that's what makes a prism a prism. But if I tried to find the volume of this, I'd have to find the area of the base, which would be the area of that triangle, times the height, okay? This guy here, I'm gonna sound really fancy when I say this. The base, the thing I have two of, is a hexagon. So we call this shape a hexagonal prism. Sounds very snooty. So hexagonal prism, because the two bases are hexagons and it's connected with rectangles. To find the volume though, same formula, area of whatever the base is times the height. Okay? So I'm gonna pause the video for a little while, or maybe just start a new one, because now I gotta actually show you how to work out some of these problems. And I gotta get organized and change the layout of this video. So I'll see you in a minute.